So, yes, hello everyone, and welcome back to Calculus 1000. Today is the day we learn about one more thing about differentiation. So far, we have been, okay, at the beginning, we tried to understand what is derivative, yes? Like the definition, f of x minus f of a over x minus a. And then we got some understanding of what is this giving to us, rate of change and slope of tangent line, yes? But then, after that, we have been doing only one thing, which is give me more differentiation rules. Let me know more of functions, how I should differentiate. In all these methods, the table of differentiation, now you should have all the rules there. Power rule, chain rule added to the product, quotient, sum, the constant, multiple. Also, we learned about trig functions, derivative, inverse function derivative, inverse trig derivative. Now, we will go a little bit off this road, just a little bit, because what we have been covering so far was for functions we call explicitly defined. In other words, these are the functions that you have y equals an expression in x. It is y is explicitly defined as function of x, meaning that if someone gives you a value of x, you just plug it into that expression, you get y value. Well, for these guys, finding the derivative is basically using the rules that you already learned. Differentiate through the rules. This I will write here, y is a function of x explicitly defined as. Yes, so it is everything clear. We know the differentiation rules. We do what we need to do. There are functions, when it comes to the real math, there are functions that are not explicitly given. Instead of having y equal an expression in x, we have an equation in x and y, an equation in x and y that together they define a dependence of y to x. So we call these ones y is, again, a function of x implicitly this time defined by this equation. For example, simple case of this is this guy. Do you remember what kind of object this equation defines? Circle, yes? And you look at circle, wait a minute, there's something wrong with circle. Circle is not graph of any functions. It fails the vertical line. Why you're interested in finding the derivative there if there is no function? That's a good concern. However, if I look at this circle and I give you any given point on that, this is one way of, by the way, one way of trying to explain this. Without worrying if this is the graph of a function or not, I can ask you, what is the slope of the tangent line to that curve, which happens to be circle, at that given point? And as you know, the slope should be given in some form as dy dx. Yes? Even though y, if I want to explicitly write y in terms of x, it's not going to work. But every single point on circle you give me, I have to be able to find the slope of tangent line to the circle at that point. And this is one way to look at it. There's also another path that's a bit advanced and says that locally, if there are good conditions, you can see every graph as graph of a function, which is a story you don't need to be worried about. The only thing you need to know is that even though the curve is not a curve of a graph of a function, but it still makes sense to ask what is dy dx, or slope of tangent line at that point. So an equation in x and y is given, and the question is, what is y prime? I am not going to add any differentiation rules to what we already had since yesterday. I'm not going to add anything. But this is a trick that tells me that all those rules now can be in some ways applied for this implicitly defined equations. Let me go step by step on this specific example, and then we go in general case what we do. There are three things that you need to do to be able to find y prime. The simplest, the first step is that you differentiate both sides of this equation. The equation, you can write always of that form, or if there is left-hand side, right-hand side, you can do derivative of the left-hand side must be equal to derivative of the right-hand side. Well, if the derivative makes sense in some ways, two expressions are equal, so their derivative must be equal too. So derivative of the left-hand side must be equal to the derivative of the right-hand side. That's a step one. Now, now I want to go slowly and apply all the differentiation rules I know. What I mean is this. Well, this is sum of two functions. So then the summation rule says this is the derivative of x squared, and this is the derivative of y squared. And derivative of constant is 0. See, I'm applying the rules that we normally use for the explicit differentiation, yes? So this is step 2. But I have to now apply more, because derivative of x squared is 2x. Nx to the power n minus 1. So this is 2x plus. What is derivative of y squared? 2y. OK. Y 2y. This is something that I want you to learn at this moment, and don't make this mistake again. If I ask you what is derivative of y prime, if I ask you what is derivative of y squared, the correct answer is that, continue, what is your question? I have to tell you I'm differentiating with respect to what variable? If I am differentiating with respect to variable y, here I'm not doing that. But if I am differentiating with respect to variable y, then in that case, the answer is 2y, the one that you pointed out. But if I am differentiating with respect to another variable, what would that be? Yes, please.
2y times dy over dx.
Can you tell us what is the name of that rule that you're using?
To differentiate.
No, it is. Do you know? You know the name? Yes. Chain rule. Don't make it more complicated than it is. This is chain rule. See, I already said that y is a function of x. That means that when you're differentiating with respect to x, you have to consider y as a function of x. And when you have a function of x, you differentiating, you use the power rule plus chain rule in cases like this. In other words, it will go like ny to the power n minus 1, but then the chain rule says that you have to multiply it by the derivative of the inner one. Remember, chain rule plus power rule gave us u to the power n, you differentiating, you get n u prime u to the power n minus 1. Here, that function is y. Okay? So we continue this. So this will be 2x plus 2y prime y equals to 0. There's nothing else to do. I did all the differentiation. But remember that I was asked to find what is y prime, or what is dy dx. Now, I have an equation for y prime. I have to solve it for y prime. In other words, I have to isolate y prime there, meaning that send everything which doesn't have y as y prime to the right-hand side. So this is the third step. 2y prime y is equal to negative 2x. Then result, as a result, I get y prime is minus 2x over 2y, or just simply minus x over y. Yes, please.
On this board, you wrote d over dy, and then you changed it to d over dx.
Sorry, what was it?
Why is it d over dy?
So this notation, I'm noticing that this notation is sometimes a little bit confusing. What does this say? This says differentiate this expression with respect to the variable given there. Yes? So when I write d dy means differentiate with respect to y. It's like differentiate x squared with respect to x, that's 2x. Or in terms of y, it's 2y, yes? I can change this to any variable I want, yes? The key point here is that when you have different ones, and one is function of the other one, you can still differentiate the same rules, but you have to add that chain rule somewhere there, yes? Any other questions, any other comments? These 3 steps are what you need to do. All starts with, okay, if I want to say it very easy, less steps, I would say differentiate, solve it for y prime. That's all you need to do. You look at this thing, the final answer, you may ask me, well, isn't this supposed to be in terms of only x? We have been differentiating all the time, and y prime, dy dx, or f prime, was always, we would be able to write it in terms of x. But here, now you have both x and y. What should I answer that question? Well, how should I answer that question? Wait a minute, you didn't give me even the function to start with in the normal way. You gave me as implicitly defined function. You cannot expect me at the end when I'm finding y prime, I write it only in terms of x. And in the implicit differentiation, the result would have always, or most of the time, both x and y. And you don't need to be worried about why there's x and y, both of them in this equation. That's one comment that I would like you to keep in mind, but let me write the steps now here. Implicit differentiation. Step 1. See, I did exactly what I did there. I want to write it in general form. First, differentiate both sides. both sides with respect to WRT, with respect to x. In other words, I want you to write this one. Left-hand side of the equation, d dx of that, must be equal d dx of right-hand side. d dx of left-hand side must be equal to d dx of right-hand side. Step 2. Apply all the differentiation rules you know. Specifically, when it comes to differentiating y terms, you have to use chain rule for that. So use differentiation rules. And remember that chain rule, the chain rule needs to be applied for terms in y. As a simple, for example, e.g., d dx of y to the power n is going to be n y prime y to the power n minus 1. Or derivative of sine y is not cosine y. You have to multiply it by y prime as well. So you have to use differentiation rules when it comes to the y terms, the versions of differentiation rules which have the chain rule in it. Step 3, isolate y prime, or solve the equation you get for y prime. Solve for y prime. Yeah, these steps are trying to help you with kind of, it's not much of, the steps themselves are not important. These are just helping you to follow something. What matters is basically differentiate, solve for y prime. That's all you need to do. Any questions, any comments before I try to do one or two examples? Yes, please.
When it has both x and y, can you isolate for y in the original function and then put it in so that it's only x?
So what you're saying is that if I can turn implicitly defined function into explicitly defined function, can I do the explicit differentiation? Well, writing a function, an equation that is not easy to turn it into the explicit form is not difficult. When you get an equation in x and y, forget that trick of maybe I can turn it explicit form and then differentiate. That's not going to work most of the time.
And if you have x over y, if you just isolate for y with the first one, can you plug that in to the denominator, or would it just be wrong?
Oh, you want to simplify this furthermore. I won't expect you to do any of those ones. If you could simplify, if you could isolate y in the original one, why would we need to do all the implicit differentiation? Does that make sense? Yeah. Any other question? Any other comments? Let's do some differentiation then. Implicit differentiation. Examples. differentiate or find y prime. If x plus y over x minus y is x squared minus 2, or this is another example. Three simple steps, and all you need is basically the differentiation rules. I'll give you 2 minutes to work on these examples. I would at least expect you to do all the way to step 2 in this one, and at least start beginning of step 2 for this other example. 2 minutes starts now. If you stuck, talk to the person sitting next to you. That would definitely help you more than I'm just sitting here watching my tablet.
No. Derivatives of y times 1. Y is a function of x. As a function of x. If it's a function of x, like x minus 1. Minus 1. Yeah. The derivative of what? The derivative of what first? The derivative of the square. You know what? Just ignore that. I can't.
Twenty seconds.
All right. Wait, you forget bush? I'm sad.
Okay. I start with differentiating left-hand side. And it must be equal to derivative of right-hand side. Now, right-hand side, the derivative is easy because that's just 2x, yes? 2x minus 0, just 2x. But left-hand side, we have fraction. So our quotient, I have to apply quotient rule here. The way, bless you, the way it will work is this. Derivative of numerator, let me just write it this way. d dx of x plus y. And then times the numerator, the denominator, minus numerator itself times the derivative of the denominator. And then the denominator squared. That's the derivative of the left-hand side. Derivative of the right-hand side is easy, and it is just 2x. Okay? I am not done yet. I have basically given out the work that I need to do. Here, I have to get rid of this d dx's. So I have to actually evaluate that. It means derivative of sum of two things. Derivative of first one, derivative of x's 1. Derivative of y is, we'll just write y prime. Yeah. And then you write x minus y minus x plus y. Derivative of, again, x is 1. Derivative of that is, yeah. Just to save me one step, there is no y prime here. So I can multiply this to the other side. So this would give me 2x times x minus y squared. So that will save me one step at least there. Now, I'm done with differentiation. I have to solve for y prime. Isolate y prime. You can do different ways. Well, what I like to do here is that I try to multiply these things, not expand all the way, but just enough that I have y prime times something. So this means I will have 1 times x minus y, I'll write it that way, plus y prime times x minus y. Then 1 times x plus y, negative negative is plus y prime times x plus y. And that is 2x x minus y squared. I'm just trying to simplify so that I can put all the terms with y prime on the left-hand side, take everything else to the right-hand side. Here, this term and this term, they have y prime. So I can factor out y prime from this and that. And what I will get is x minus y plus x plus y. Yeah? Is that good? Did I make a mistake? You should tell me if I made a mistake. Okay? I know if I made a mistake, no, someone at the end of the class will tell me, oh, that was negative. Okay. So here, I have x minus 1, x minus y, minus x plus y. So x's cancel each other. I get this piece. So I put this with that together, and then I put this and that, and I factor it out. Yeah. And now, OK, look, this also, there's a cancellation here. I get 2x y prime equals 2x x minus y squared. I take this 2y to the other side. Done, almost done, yes? I just need to divide both sides by 2x, and I'll get this divided to the right-hand side divided by 2x. That's the y prime that we were looking for. A question may come up that how complicated this equation for this last step could be. Could it be that very complicated derivative equation for y prime can happen? The answer is that if you have done everything correctly, always you will get one of those equations that there is an expression times y prime equals another expression. You will be always to isolate it that way and then divide the coefficient to the other side. If you have done everything correctly, if you messed up somewhere differentiating, then something strange could also happen. Any questions, any comments here? Yes, please.
Further simplify, or is this defined?
Most of the time, in the assignments, in the midterm final exam, we will post a big, bold comment saying that do not simplify when it comes to differentiation. And no matter how much I want you to simplify it, there will be another level that someone can do it. So I am not interested in knowing how much you can simplify. I am interested in seeing this part of your work. And I'll leave it like that, just raw, so that people can see what you have done. Yes, please.
Are you not able to like combine the 2x and make it 2x and like factor them?
Yes, I mean, there are simplifications that you can do there. But I'm not interested in seeing those simplifications. This, just before this, and the last step is enough. You don't need to do more simplification. OK, let's do this other one. Derivative of left-hand side equals to the derivative of right-hand side. I want to find now derivatives. Derivative of tan x is louder. Derivative of tan x is what will happen? Derivative of tan x is secant squared. But here I have tan y, so it will be secant squared of y. I'm sorry. Don't forget to multiply it by the derivative of y. That's how the chain rule works. Y prime secant squared of y. Now, on the right-hand side, I have two functions multiplied. So I have product rule, d dx of first one times second one plus first one times the derivative of this. And now I can go ahead and try to simplify things. Derivative of y, we denote it by y prime for now. And derivative of e to the power x is e to the power x. I'm done with the step 2. All the differentiations that I needed is done. Now, there's only one thing. Solve it for y prime. There are two terms which have coefficient y prime. So I can bring both to the left-hand side and factor y prime. Here, note that I'm taking this to the other side. There will be negative sign. That's the negative sign over there. And then y prime is y e to the power x secant squared y minus e to the power x. Any questions, any comments there? Let's do some more differentiation then. Yeah? Okay, maybe, do you have any questions? You can ask me. Three simple steps, but sometimes you need to be worried about the algebra that you're doing there. Find an equation for the tangent line to the graph or to the curve defined by this. Oh, sine of xy equals to 2x plus y squared minus 1 at 0, 1. Okay. Two things when it comes to the tangent line, or any line actually, you need two things: a point, a slope. Here, the point, it seems it's given. How do I know that this point is a point on that curve defined by that equation? Yes, please?
It's a tangent line for the original f of x.
It is supposed to be like that, but as a person living somewhere who I'm not sure if this question is written by someone who knows very well math, how can I check that this is a point on the curve? Like this curve, I don't know what is the shape, but I want to see if that point 0, 1 is on that curve or not. Let me see. Yes, please. Plug it in. Points on that curves are x and y's that when you plug in into that equation, they satisfy that equation. In other words, if I plug in 0 for x, 1 for y, I get sine of 0 times 1 equals, or is it really equal? That's what we are trying to check. 2 times 0 plus 1 squared minus 1. The left-hand side is sine of 0. The right-hand side is? The right-hand side is 0. And we know that that is there. So yes, point 0, 1 is a point on that curve defined by that equation. That we can confirm that. Now, the second thing is that, what about the slope? Okay, I know that if at some point there is a small piece defined by a function, y is a function of x, the slope of tangent line is the same thing as the derivative of that function, or dy dx. However, I should plug in x equal to 0 and y equals to 1. So if I know a slope, I know the point, then writing the equation is easy. Now our task is to find dy dx for the y and x that satisfy this equation. I'll give you maybe 2 minutes. Why do I feel so generous today? 2 minutes. Go ahead, please talk to the friend sitting next to you. Make all the mistakes you can make now. Don't leave the mistakes for later. This is the time to make mistakes. Go ahead, please.
Were you still following the implicit command like that?
You got it wrong. At least I put it wrong. I apologize. Y prime plus next to it's y plus y prime x. It's y times y plus y prime x in brackets times this.
It's two functions though.
Okay, what's the derivative of this? You take the product of these two functions.
Oh, right. One.
Sine x, y. Sine of x, y is just
You have 50 seconds left. I like that you're discussing. I'm hoping that it's about this problem.
Multiply by both functions inside this chain rule, right? Just like you do the product rule things.
You said multiply by
If you take the outer function, what's the outer function? Sine x. Okay, first have chain rule Hershey. Times the you don't need to put it in. Why are you putting it on the inside? It's okay. Y prime times of xy versus
That's what it is. Wait.
do itself.
Okay. So differentiate left-hand side. So d dx,
Now I can do it.
d dx of left-hand side must be equal to d dx. Must be equal to d dx of the right-hand side. Yeah? Now, well, left-hand side is easy. I can differentiate that easily. How about sine, derivative of sine xy? I sometimes like these chain rule versions of differentiation rules. I want sometimes to write them as this form instead of writing. Remember that when we were doing that, we wrote this. Yes? I sometimes write this as sine of box, doesn't matter. Give me something inside the sign. If I want to differentiate that, it's going to be derivative of whatever is inside. I can put prime. Let me do this. Times cosine of the box. Right-hand side, this is 2 plus 2y prime y minus 0. Okay. Now, derivative of box, I have to deal with it now, yes? Derivative of first one, 1 times second one, plus first one times derivative of second one. That's the derivative I was looking for. Times cosine of xy equals to 2 plus 2y prime y. And then here, now I'm done with differentiation, by the way. I'm done with differentiation. There's nothing else that I need to differentiate there. The rest is solve for y prime. So I have y prime term here. I have to first expand this. And then I'll get y times cosine of xy plus xy prime cosine of xy equals to 2 plus 2y prime y. Isolate for y prime. So bring all the terms with y prime one side. So I have 1 here. Let me erase that part. So that's xy prime cosine of xy. Bring this to the left, minus 2 y prime y equals, I have 2 here. I take this to the right-hand side. Well, I could have done y prime factorization here. Yeah? Now I'm done. I just need to multiply this whole coefficient, or divide the right-hand side with the coefficient of y prime, which is 2 minus 2 cosine of xy over x cosine of xy minus 2y.
There's an extra 2.
Sorry, what was it?
Where did you get the 2? That's in front of cos x1. Yeah, on the right hand side, it says equals 2 minus 2.
Maybe there's no 2.
Yeah.
Maybe there's no 2. I'm just creating some 2's there. Wait, that's y, isn't it? Yes, it's y, sorry. You're right. This is y. Yes? Here I have y there, yes? I take to the left-hand side, right-hand side, that's negative, and then left. Thank you, thanks. I think the rest is good. I think the rest is good, yes. Okay, are we all happy so far? Doesn't seem you're happy. Are you all happy? No, I need to hear a good yes. Are you all happy? He says no in front of me. Someone from there, they can say no because I don't see them. Okay, we need to talk after the call. Okay. I found the general derivative. Now I have to plug x0, y equal to 1. So that would give me 2 minus 1 times cosine. Cosine of 0 times 1 is cosine 0. And x is 0. Cosine of 0 minus 2 times 1. That gives me cosine of 0 is 1, 2 minus 1, and this is 0 minus 2. 1 over negative 2, that's negative half. I found the slope. I have the point. Then the rest is just a simple plug into the formula for the equation of line y minus y1 equals to m x minus x1. Y minus 1 equals to negative half x minus 0, or in other words, that is the equation for the tangent line to the graph of that curve, or that curve defined by that equation. Yes, please. Yes.
The y and x into the.
No, y. Oh, no, 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 no. Look, I'm looking for tangent line. It's an equation for line. It's y equal ax plus b. I don't need to sub in anything else there. I cannot hear the question that your friend is asking. Yes. Y prime, I found the general y prime there, but I want to use that to find the slope of tangent line at this specific point. So I'm plugging in x and y to get the slope of that specific tangent line. Oh, I see. You can, the question is now, I can, what's going on? I usually get 1 extra minute. Now you guys are starting going out and standing over there even 5 minutes before the class ends. If you are interested only finding the slope at that point, yes, you could plugging into this step, yes? And just find it for that specific m. But I was trying to find the general derivative and then plug it in. Either way would work if the question specifically asks you to find the slope. You want to go today, I don't know why. Have a great day, see you all tomorrow.